Hello everyone, welcome to watch our video. See, our lesson today is talking about the natural logarithmic function. Okay, before I begin to find the derivative of natural logarithmic function, I have to know what is the meaning of natural logarithmic function, which means ln x. What is the meaning of ln? It means log base e of x. Log base e, it means ln of x. Okay, I'd like to know how to find the derivative of natural logarithmic function. As you see, the derivative of ln of x, it will be 1 over x. That is the rule. That is what? The rule. Okay. Here, find the derivative of a composite function. Its outer function is what? Ln, and its inner function any other function. It will be the derivative of the inner function u, but I have to identify what is the inner function, what is the value of u. Okay, u, it means the function that we take ln at it. U prime over u. Let's see how we find the derivative of natural logarithmic function as in the following exercises. Okay, look here for this example, you will see how we find the derivative of natural logarithmic function. Please focus here. For example, to find the derivative of this function, ln, what is the derivative of ln 2x? Okay, the derivative with respect to x, the derivative of this function. Where is the inner function? As you see, the inner function here is u. Is what? U. The derivative of any natural logarithmic function or a composite function, as you see here, ln and another function, it will be u prime over u. U, as you see, it is 2x. What is the derivative of 2x? It is a linear function. It will be 2 over the inner function, which is 2x. Simplify it, it will be 1 over x, as you see here. Okay, I think it's so trivial. Let's solve the next problem here. Ln, how to find the derivative? Ln x squared plus 1. Okay, the derivative of this function with respect to x. As you see, the variable that we find the derivative with respect to it as the variable of the function itself. Okay, so it will be u prime over u. But I have to know, where is u? This one. Okay, that is the inner function. What is the derivative of this function? The derivative of each term, what is the derivative of x squared? It will be 2x. Plus the derivative of 1, it is a constant, it will be 0. Can be submitted, I don't need to write plus 0. Over this function, which will be x squared plus 1. That is my derivative of this function, or the differentiation of this function, as you see here. Here, as you see, I find the derivative of what? Function and another, that is u, that is what? V. I have to identify which rule we will apply first. If I have a product of two functions, this means I will apply that product rule. If we have a quotient of two functions, I will apply the quotient rule. If we have a composite function, I will apply the chain rule. Okay? Keep the rule with you when you are watching the video or when you are studying, when you are doing that. Okay? It will be, as you know, u v, the derivative of a product of two functions, u v prime plus v u prime. Okay, the first x. What is the derivative of ln x? As I know, you have to remember the rule. It will be what? 1 over x here. First multiplied derivative of second plus second multiplied derivative of first. That is a product rule. I don't need to write all of these steps, but if you know how to apply it directly, go ahead, okay? It will be x multiplies the derivative of ln x, which is 1 over x plus ln x multiply derivative of x. I know the derivative of x with respect to x is so clear, 1. Okay, simplify x multiply over x1. So that is your answer. That is your answer. Okay, for the following one. Here, as you see, the derivative of ln x all to power 3. Since you have a bracket raised to power, we will apply general power rule. It will be the exponent u n minus 1 to power n minus 1 multiply u. So according to the given function, I have to know which rule I'll apply. Okay, here you give me bracket raised to exponent. I'll apply the general power rule, which states what? The exponent multiply the bracket, decrease the exponent by 1. Here, what power 3, it will be to power 2. Multiply the derivative what inside the bracket. So it will be 3 ln x all to power 2. Multiply the derivative of ln, which is what? 1 over x. That is your answer. It's very interesting lesson. Okay, enjoy. Here, with this one, I think trivial. Just apply the rule directly. Okay, I don't need to rewrite the function. Just apply the rule. Ln u, the derivative of ln u, it will be u prime over u. Where is u? The function that we take ln, and it will be what? Its derivative 2x over what? X squared. You have to rewrite this function in the simplest form, but sorry, here implied that is g prime, not g. That is the derivative. Okay. I divide both numerator and denominator by the greatest common factor. Here for the number 1. For the variable, I take the variable with the least exponent to be a common factor, which is repeated in both numerator and denominator. Like x divide x. So it will be here, 2 here, it will be x. That is the answer in the simplest form. Okay. How to find the derivative of this one? Where is u? So the derivative of h, it will be u prime over u. What is the derivative of u? I know all of you know how to apply the basic rule of differentiation. Okay, what is the derivative here? 4x plus what is the derivative of 3? Derivative of 3, it will be 0. I don't need to write it. Okay, it will be 2 over u. What is u? Here, as you see, the function that we take the ln at plus 3. That is your answer in the simplest form. Here, by the same way, I find the derivative of this function, which is a bracket raised to exponent. Okay, it is the general power rule. Imply the derivative of this function, it will be the exponent, multiply the bracket, decrease the exponent by 1, multiply the derivative what inside the bracket, which is 1 over x. To simplify, it will be 4 over x, multiply ln x to power. Easy. Okay. Sometime I began with applying one rule, but after we apply this one, I need to apply more of basic rule. Here, as you see, I have a product. So I will apply what? Product rule. So the derivative of this function, the first, multiply the derivative of second. What is the derivative of ln x? I can write here u equal x. Its derivative, what is the derivative of x? It will be 1. It's the coefficient, or as you know, the x with respect to x, it will be The derivative of x with respect to itself, it will be 1. B, it will be ln x. Imply in the derivative, it will be 1 over x. Use a cross. You can use this way. Okay, but some of you can apply it directly without identify what is u and b by this way. Okay, it will be x multiply 1 over x plus, okay, ln x, which is the second one, multiply the derivative of first, which is 1. So it will be here, it will be 1 plus ln. That is the answer. As I told you before, sometimes I need to apply the properties of natural logarithmic function before I apply the basic rule of differentiation or the rule of differentiation. What are the rules that we need to know before I find the derivative? Look here, ln x multiply y, it will be ln x plus ln y. It means ln product of two functions, it will be ln the first plus ln the second. That is the first rule. What is the second rule? Ln x over y, it will be ln x minus ln y. Ln quotient, it will be ln the numerator minus ln the denominator. Ln x to the power n, it will be n ln x. Okay, any power function, it means it will be the exponent multiply. I need all of these properties. The first one, ln e to the power x, since I know the natural logarithmic function and the natural exponential function are inverses to each other. So ln, okay, cancel exponential function. Natural logarithmic function can cancel what? Natural exponential function. So it will be x. The fifth rule, e to the power ln x, it will be x. Okay. E to the power any number, it is a constant. It means the value of the function at this one, as I showed you before. When we substitute by any value in a function, so I will get a numerical value, I will get constant, okay? Here, ln x to the power x, yes, I know, ln and e cancel each other, it will be x. I rewrite the function first by using the properties of natural logarithmic function, then apply the rules of differentiation. The derivative here of this function, it will be 1. I think it's a trivial. Here, as you see, e to the power 3, that is constant. That is what? Constant. So to find this, the derivative of this function, it will be this constant multiply the derivative of natural logarithmic function, which is 1 over x. So it will be e to the power 3 over x. Trivial. Okay. Here, Miss, like this problem, I know I can solve it by the other's way, but it will be too long and more difficult, and it is not easy to simplify it. But it's better for me to apply the basic rule, the properties of natural logarithmic function, then find the derivative. How to simplify it? Why? It will be ln x squared plus 9, minus 9 or to the power half. Apply this property, which is what? Power rule or the power property. It will be what? Half ln x squared minus 9. That is the rewriting of this function. As I told you many times, rewriting it doesn't mean the derivative. Then find the derivative of this function, which will be this constant, multiply the derivative of this function, which is what? That is u. The derivative of it, which is 2x. The derivative over u itself. I know derivative of ln u. It will be u prime over u. So it will be x squared minus 9. Simplify it, it will be 1 over x squared minus 9. I think it's easier for you. I can write u prime, find the derivative of this this radical function over this function, but it will take a long time and it will be so difficult to simplify. But if I use the property of natural logarithmic function, it will be so easy as you see. Okay, let's solve the next problem. So trivial. Yes, I know. If I find I name this. If I name, look here, I'd like to tell you something. If I refer to this quotient as u, I have to apply the quotient rule over u. It will take a long time. But here I apply the property. This quotient property of natural logarithmic function, it would be len numerator minus len in denominator x squared plus 1. That is the rewriting of this function. Then find the derivative of first minus the derivative of second, which is u prime over u. It will be 2x. What is the derivative of this? 2x over x squared plus 1. I need the skills of simplifying a rational function or the operation or subtraction addition on what rational function, rational expression. But anyway, how we subtract these two rational expression or these two rational function, it will be x, their product, then multiply this one here, it will be x squared plus 1. This one multiply, it will be minus 4x squared. Then simplify, I'm sorry, leave 2. This term, x multiplied to x, it will be negative 2x, okay. Keep the denominator as it is, as you see. Or I can expand on find their product, no problem. It will be 1 minus x squared. I can write it to be in this form, no problem. Any one of them, it will be right, okay? Plus x, just distribute. I can write it in this form or in this form. Okay, by the same way, I need to rewrite. It's easier, but not wrong to you find leave this one u and apply the quotient rule, but it will be too long. Okay, it will be len 2x minus len 3 x plus 3. Then find the derivative of this function after what it's rewriting. Okay, it will be what is the derivative? I name this u for this one, it will be 2 over 2x minus this one, I limit u, it will be 1 over x plus, it will be 1 over x. Simplify it, I multiply x plus 3. What is the numerator? Multiply here. It will be, to avoid any confusion, okay? Multiply here, it will be x plus 3 minus x. Cancel. So it will be 3 over x multiply x plus 3. I think if we use the properties of natural logarithmic function, it will make the differentiation easier than before. Okay, I think we have finished the answer of this sheet. Okay. Thank you for watching the video and have a nice day.